Alright, this is the About Me section. So, I'm 23. I was born in Peru, 1990. So after that, 2 years later, I moved to Washington D.C. and I lived there for like 6 years. And then when I was 8, I moved back to Peru, and I continued with my like middle school, like elementary, actually middle school, high school, and then did my undergrad in Peru too. And now I'm here, and I moved to California finally after like 22 years maybe. So some personal things about me is I've always felt that even though I am Peruvian, I was raised in DC, so I kind of like identify myself with kind of like both American and Peruvian cultures, um, and it's kind of weird, but I like it, and there are certain stuff that I like from both cultures, certain stuff that I don't like from both cultures, but that shaped the person who I am. And an interesting motivation of why I'm saying this is because I believe that sometimes the culture affects a lot when it comes to research on the long run, as in like the attitude that you have to have, how education is shaped in different societies too, the different paradigms of how people pick a career or an undergrad for their undergrad, and it varies from place to place, from city to city as well, and I'm pretty sure it varies from whatever country you are, and it's different and it's weird. Sometimes for the good or the bad, but that's just like how it works. So I always like kind of had this mental thing where I always wanted to like go back to America, and I think that was kind of like a deep, weird motivation for why I just wanted to do grad school too. There are other scientific motivations that I have, and I will explain further on. But like a personal motivation is I just always, I still do feel kind of foreign sometimes, even in Peru, which is home for me, and I still feel foreign here. It's like, and in the times I visit DC, which is my home, I don't know. It's everything is in peace, and I just feel that it's an amazing sensation that I don't know how many of you guys have ever felt, that you just, everything is just peaceful. There is no more happiness after that. Happiness in like a way of fulfillment. It's just amazing. Anyway, so the thing is that when I finished high school, I was pretty much interested in a lot of stuff. I liked to paint a lot. I was really good in math and in physics, but I always like kind of like wanted to be a scientist, and I always had this idea of wanted to make a robot, and I was always like fascinated by electronics and like knowing, even though I did, because I didn't know how it worked, right? I'd see a computer like a radio, and I'd be just amazed of how a transistor, like a circuit board, would just do a lot of stuff that I had no idea 7 years ago. But now I kind of have a better idea, given that I majored in robotics, of how like it works and everything, and that was like a main motivation that I had. And eventually, my decision for majoring was in a public school, not a private school, which is usually better in developing countries, as in Peru. But I went to a public school, and I kind of like have mixed feelings about how I enjoyed it there. I think on a day by day basis I didn't, because it was very time consuming, to the extent that I would not go out sometimes like for an entire year. At the beginning, I would not go out every single weekend, and that was, at the end, that's like very, very counterproductive. And you notice that when people finish grad school, that sometimes, I mean undergrad, that sometimes it's more than just taking courses, and this goes for any person, anywhere that person is. Whether you're going to MIT, I have friends from MIT who go here, and they've told me the same thing, that the only thing that they hated there was it was just so time consuming. But eventually, obviously, they're in a very good position now, right? I think at the end, it's just a lot of, you have to put a lot of time and effort in what you do and what you love to get where you are, where you want to be. And back to what I was talking to. the whole thing of just investing time and only studying the first years is kind of counterproductive, because at the end you see a lot of what they call the stereotypical nerds that I think every one of us has been, or like I still consider myself one, is. So at the end, like, people sometimes who are completely devoted to just studying just can't go beyond that, because when you go to grad school, or you want to go to grad school, grades I mean, they do matter. In grad school they don't, but grad school isn't about taking more courses. Grad school is about research. Grad school is about not people giving you a problem, but it's about you finding what the problem is. And it's not like an undergrad where if you don't know the answer to a problem, you're going to ask the professor, and the professor's going to be like, all right, read this book or whatever, and you'll probably find the solution. In grad school, usually, first you don't know what the problem is. You have to figure out what problems are worth solving, and then you can't really ask anyone about the answer. It's like no one knows the answer, and that's why you're in grad school. You want to find out the answer to that specific problem. Graduate school is a lot of like trying to discover something, if you romanticize the idea, but it takes a long period of time, which is eventually the duration of the program, which is usually like the average of 5 years, and it depends in what field you're going to be. And going back to me and I always skip, by the way. Sometimes I just like diffuse into idea and just like go back. Going back to my undergrad years, I think I still have mixed feelings about that, and I eventually started out very much as a person who was only dedicated to studying and getting high grades, until something interesting happened, which was that after my first year, I visited my aunt in California, which is where I am right now, but she lives in San Diego, and I remember just giving a tour around UCSD, and then driving. She'd lend me her car, and I drive to Caltech and just like take like those undergrad tours, and I just loved the place a lot, and I was like, damn, it must be like really awesome to be here surrounded by a lot of smart and hardworking people. And from that I just got the initial idea of, okay, I want to stop going to my school in Peru and just like transfer to another school in USA. And what happened was that I studied for the SAT, did the usual, did my research on like how to apply to for a transfer in the undergrad program and everything, and I applied to 4 schools. I got rejected by the 4 schools. This happens all the time, so it's no big deal. A lot of people get like, think it's the end of the world when they apply to a school and they get rejected. No, it's not. It's part of the process. Failure and rejection is part of the process, and you have to get used to it. I got rejected by 4 schools, and I was I think second or third best in my class, and I scored 2 800s on the physics and the math level 2 SAT, so I got a perfect score, and I still got rejected. So I got rejected because I put some like really stupid stuff on my application essay that I might write below in the comments if you guys want to read that, because it's very embarrassing to talk about that in a video. And after that, I just like realized that I was doing something wrong, because if the only thing that I was doing was studying, and I was at the top of my class, and everyone at the department knew that I was a good student, but I still didn't get in, it's like, what more can I do to get in? It's like I felt that I maxed out. It's like, what is the way if that is not the way? And that's where I just like suddenly got puzzled, and I accidentally met this guy who introduced me to my previous advisor in Peru, and he started telling me like, oh no, you know, when you want to apply, whether it's undergrad or like grad school, you have to talk about research experience. Those schools like Berkeley or like Stanford wants to know like what you've been researching, and not they don't want an essay of you telling them how smart you are, because they already know that. You have to prove that you've done something interesting, and it's something that you like, and that'll be just like self-expressed once you write the essay. And I had failed at that because I didn't do any research. I had just been studying, and like that was it. That was like all of my life. So I just had to put a pause on that, and I didn't know what else to do. And he was like, well, you can do research. And I'm like, okay, but what is research? How do I do research? Where do I start? And he started giving me these like random books and texts on systems biology. I'd read some stuff as well, maybe on I think it was molecular dynamics. I'm not familiar with those areas, by the way, but I started reading in reading stuff, materials, like websites, every possible thing available related to the area that he had assigned me to, and then a specific project. And I think even though I really didn't get that deep into that field, it was a good first introduction to something, because you have to know how to read, get a lot of different sources to actually come to a conclusion in anything, in almost any subject that you do. And it's also good to identify what things you did like versus what things you did not like when you were doing a project or a research project, or just like reading overall. I found out that I would get bored and I would like start sleeping like in the monitor screen, and the professor would see me and he'd be like, "Why are you at my lab if you don't like biology?" So eventually things started not really taking off. We kind of had a weird discussion, which is interesting, because usually when students and their advisors fight, it's like, it just like, there's no recovering or turning point from there. And I remember I'd always go to his office once a week, like every Friday after class. And it's good if you actually know a professor who has a PhD and he does research in any other subject that's not necessarily what you want to do research in. It's always good to talk to these people because they have a lot of experience. They've done research because they have a PhD. A PhD implies having research experience. And I'd just go there for advice, and I'd be like, yeah, I want to, whatever, have this real dream of going to MIT or like Harvard or whatever. And he'd like first kind of reorient my ideas and like try to tell me, don't go for like the school, go for something or like an area that you want. Find first something that you want, because you're just coming here and distracting the other researchers at the lab by talking too much about your ideas or wanting to go to Caltech and how your summer vacations were or whatever. But you're not. I don't. And he told me, I don't see you sitting down and doing research and like coming here with a good idea or reading interesting papers or telling me, I found this paper, what do you think about this? I still haven't seen you do that for an area that you like. And at the end, he just like kind of kicked me out of the group after a long walk in the park. And I appreciate that, because it kind of made me realize that I wasn't accepting the reality of me not knowing how to do research and talking about how I did it when I actually did not do it. So after that, we didn't talk for a while, and I wanted to come back. I wanted to prove to him that I could do research, that I wasn't just like, as they say, like a poser or whatever. And so what I did was I spent like almost half a year just going on Google like every single day and start looking into different subjects that I'd possibly like. This is an important step. You have to first have some sort of general idea of what you would like to do. So for example, in my case, and it eventually happens with different courses and class projects like you'll have, I identified that first I didn't like biology, which I've told you guys before. Second, even though I got into robotics because I really like electronics, when the time came to actually make a robot, I just hated like the whole circuit design thing and getting to know what transistor I should use or programming the microcontroller. I learned how to do those things, but at the end it's like I really found out that it's not what I enjoyed. I did find out that I enjoyed, for example, doing the mechanical design of the robot, which is kind of simple, even though I do some SolidWorks and some like relatively simple drawings, whatever, like specific tension design or that type of stuff, or like material resistance stuff, or like what's the, no, it's not CAD. I think like CAD simulations, like finite element analysis, nothing that detailed, but just like I like to design the shape of like a robot. I was like really into that artistic thing, but at the end I just like found out that, all right, that's good, that's interesting, but that's like more into industrial design, which when you actually like put the pieces together, it's not, well, it's kind of like an engineering, but there's not a lot of well, there might be some math and physics, but it was like going into another road, and I thought that my contribution, if I wanted to do into science, should be, it could be different, or I could give more. And I actually found out that if the real thing that I liked was design, then I should have started shifting towards art maybe, which I enjoyed too. But then I started noticing other things about this robot project that I did. For example, I noticed that the robot was kind of dumb. I noticed that the key thing, like in the small line follower competitions, or like the sumo robots, which is a robot that we did, like the AI factor, or like the algorithm that you're gonna code inside the robot is very important if you want the robot to win in the competition. But I just hated the coding part, even though I recognized from taking a programming course that I was good at coding, programming overall, and some like algorithms stuff. It was very intuitive for me, but I just like didn't like the idea of sitting down on a computer. Well, I do now, kind of. That's another topic. But I recognized that and said, okay, so maybe AI, right? And it's kind of like, if you notice, like an exploratory process where you have to go into one subject to then notice what you like and what you don't like, and then kind of like pull out from the subject, explore something similar or maybe something completely different, but then just keep on recognizing what you like and what you don't like, and if that like really excites you, because you won't really know if you really like doing something until you actually sit down and do it and invest hours, days, weeks, months into a project. And that's another thing about just people when it comes to doing research, just like giving up. I felt many times that when I started out, there's always like small barriers that I had. Really small barrier, for example, was learning Linux. I think everyone at one point does a transition from Windows to Linux, and for me it was kind of hard. And then I just keep on like what's this called, like reinstalling Windows on my computer, because like I'd screw up the operating systems, and I'd overwrite like the two operating system partitions in the hard drive and stuff like that, but I learned through experimentation and error, and I like overcome that barrier. And I'm pretty sure, and I have friends who like, I tell them, hey, like, have you tried this out? Have you done it? They'd be like, yeah. And how was it? They're like, oh no, man. I mean, it's like I accidentally did this, and now like my laptop screwed up, and I have to like reinstall Windows. And I'm like, all right. And did you like reinstall Linux again, or like your favorite distribution, whether it's Ubuntu or Fedora or whatever? I'm like, oh no, dude, I just don't want to do it. It's too risky. So that's like a very low threshold barrier to get into, like, because a lot of research, like state of the art, is done in Linux, and you just like learn a lot about like computer engineering and architecture, and just like playing with the terminal and like bash scripts, and it's like a very small barrier, right? And then like barriers keep on going up, like the bar keeps on raising, and you just don't notice sometimes, and people will throw the towel when they arrive at some kind of a barrier, and they'll just like think it's impossible to surpass, or think that someone else has some sort of magical ability that they can do it, or they think that you have to take a course to actually learn something. And so the entry barrier is always kind of holding people back. Then the next barrier would be, all right, learning something by yourself, right? That's also interesting. So getting back to my exploration process, I was kind of like, okay, I don't like biology, now robots, AI. Okay, now we're there, right? Next step, learn AI. So my first course in AI was actually at the end of my undergrad career, but I started learning independently when I was around in my third year, I think. I just like started picking up books and reading articles and finding publications. I look up conferences and all that online. And the thing is, people think that that's something that you can do just like in a day or in a second. And no, like to get to that level of just knowing immediately where to look, it takes hours and like weeks to eventually know where everything is. It's a lot of dedication. And something that I'd always just like propose to myself is, all right, I'm going to sit down at my desk, no Facebook or Google Chat or whatever, no standing up. Sometimes I just like no standing up until I just like find this link for this paper and finish reading the paper. So obviously and the thing is, again, barriers, right? You find the paper, you read the paper, turns out that you don't understand the paper, which is completely normal for almost every field. I think only the only people who actually understand 100% of paper are usually just the authors and close collaborators, and maybe like the guys who are like acknowledged in the paper. But like the rest of the researchers usually just know maybe, I'd say more than 50%, maybe 75%, but like they have the general idea of what the paper is talking about and the techniques they use and all the fancy buzzwords and what they're doing, what they're trying to do, towards which direction are they trying to push certain research field. And sometimes people just like read the paper, like their first paper. I remember reading my first paper and just think it's extremely complicated and that they will never ever just like figure it out. And that's another barrier, maybe like a mid-level barrier, that you're gonna have to like psychologically just throw away that idea and say, no, I know, you have to understand that it's obviously something complicated, but that you have to invest time in understanding it. And that time will not come in a day or in a week. It's like sometimes it's months. If you're just starting out, it's months and maybe even years usually. I actually think that after a period of like maybe 2 or 3 years, someone can actually like feel ready to say, okay, I know kind of enough about this sub-research field that I'm gonna try to improve and build upon it. And that's what grad school is about. So in my exploratory process in AI, I eventually found out that I liked, since I was kind of like in the artistic side, I was like, wait, like perception is kind of fun, and like it would be cool to like have a computer or a machine that could actually like see the world and understand and recognize objects and kind of perceive the world as a human can, or in a different way, but can I perceive the world. And that was like one of my motivations, and I had to like decompose a problem, like the general problem of robotics, in the sense that you notice that the more and more you read, that the harder it is to know everything, and that eventually you just can't know everything, and that also means that you can't do everything if you don't know everything. So for the toy problem of a robot, for example, there's so many different elements, right? There's like the mechanical design, the part of control, the circuit design, the AI, whether if it's a vision system, or some other like sensory input, and maybe it's like a swarm intelligence or whatever. And there's just like so many components, and there's someone who actually like assembles a robot that doesn't necessarily have to have a technical background, but they usually do. And there's so many different things that sometimes, whether it's by science fiction or movies like Iron Man or whatever, someone that can actually think that you can actually do everything like together. This is like for the toy problem of a robot. So if it's very simple, you might actually could. But if it's like something state of the art, like the DARPA, like robots, it's like that's a team of PhDs and experts who like have most likely at least 10 years of experience in the subject, who sit and exhaustively just like work on this problem until they can eventually like recreate biped robotic motion, or like I think they have like a cheetah that runs and everything. It's extremely complicated, and you have to be kind of realistic on where you are and where you have to get. So like, what is the next barrier that you have to overcome to eventually get to that level? And eventually what I found out was what I really liked was computer vision, because I started reading a lot of AI stuff, and then I started playing with, computer graphics isn't really AI, but I started playing with that, and I realized that my interest wasn't in generating like images or videos or generating scenes. It was more in analyzing them mathematically, and it had like computer vision has this like mathematical basis that I just like really liked, and I thought it would be more interesting to give like a machine or robot or a computer some type of human-like sensor, like eyes, like sight, and that's how I eventually said set my eyes on computer vision. And it wasn't until I started also playing around with different code, downloading code, reading more papers, getting to know the community, which is also important, that I figured out that it was something that I liked. And then I started doing some personal stuff. Like, I worked on personal projects. I put up my own website, and I just like kind of put screenshots of the type of stuff I do, and some of it was like really simple. Like, I do color filtering in OpenCV, and I just like put that on my website. And or I do like k-means clustering for segmentation, which is not really a good idea, but I just do it either way. And it's a small step, and sometimes people feel that because they're still giving those baby steps, they'll just never get to the to the highest, or like to more advanced levels, like I don't know, like 3D scene reconstruction, or using RGB like depth sensors too. I don't know, there's like a lot of different interesting subjects in computer vision, but like when you read them, it just like seems so hard and difficult that you would not imagine you'd be able to do it. But you can, because everyone starts exactly where you were at one point. No one like was born knowing everything, and the difference is that the people who are where they are now just put a lot of time and effort in getting to know like those ground principles well, and then just like building up on that and specializing in a certain like subfield, whether it's computer vision or any other field. And that's kind of interesting too, because even if you recognize what field you want to get into, for example, computer science is a big field. Artificial intelligence is a subfield in computer science. It's still a big field. Computer vision inside artificial intelligence, inside computer science, is still a big field. And it keeps on like going in and in and in and in. So you have to keep on searching to see where is it that you have your niche that you just like really like and are desperately into, and just like you've read all the papers, or you want to read all the papers. And even if you don't understand, you want to keep on understanding them. Like, you find a new word, oh, SVM, what is SVM? And you Google the word immediately, try to figure out what it is. And it's like this constant like recursive process of just like reading something, not knowing what it means, and trying to figure it out. And some people just like don't put the effort in that. And I think that's just it takes a lot of attitude and commitment. So I think that's like one of the takeaway, or like take home messages. I think that's what you call them, messages of this. That if you want to do really good research, you have to have attitude, and you have to have perseverance, in the sense that just because there's a small barrier, you that's not supposed to stop you. You have to think that you can solve the problem. You have to think that you can get where you want to get, even though it will most likely take more than a year or two. And the other thing, just to wrap this up, is sometimes people feel that it's too late. They have a feeling of just like thinking, oh, I'm 20. What should I want to learn how to code and I'm 20, but I mean, I just think it's too late, and they just like have that mindset, and they just like install that in their brain, and they just think it's too late. And it's happened to me too. I've like thought about that. Not when I was 20. I think when I was like 18, and I just think and compare myself and said, I'm never gonna be a world-class scientist or whatever if I'm gonna start coding at 18, because there are kids who started coding at like 8 or 10, and they're just like prodigies. And it's true, there are kids like that from many places in the world. But just because you started late doesn't mean you won't eventually catch up. You can, you might, maybe you won't. But the thing is, you'll be surprised how far you can get just by putting a lot of time and dedication in what you do. And this leads to another question, right? How much is a lot of dedication, right? That's something that only you will know. I have my personal schedule where I'm almost like, well, when I was back in Peru, not the lab, but I was like trying to do research on my computer and on my laptop, maybe sometime between 6 and 8 hours a day, apart, like side from the class, from my class time. Sometimes I'd skip class to do research. And even if it's a Saturday or a Sunday, I'd still do research. Now, that doesn't mean that I don't do other stuff. I'd still go out with my friends. I'd still like, I don't know, go to the movies or whatever and party. I mean, still kind of had a normal life. but it optimized my schedule so that I could keep on track to like that main goal of, all right, I want to do quality research in a subject and in a field that I like, so that I can eventually go to grad school and continue with this work. That has to be like the mindset that you want to have when you want to go to grad school. It can be, and it's happened to me before and other people. And it might even happen to you if it's not happening to you right now. I want to go to Caltech because it's Caltech and that's where all the geniuses are. So okay, there are a lot of smart people in Caltech. That's true. That's undeniable. But that should not be like the mindset that you have. Many of the grad students or undergrads who are at Caltech are there because they're very dedicated in what they do. They know what they want and they pursue that constantly every day. It's like almost something obsessive. And as a consequence of that is that Caltech sees their determination and their passion and their subfield and what they want to do, and they accept them. So that's kind of like the mindset you should have. And well, eventually going back to my whole education tour, once I found out what I really wanted to do, which was like